Hi, this is Mr. B from B-Town Mathematics. This video is to help you understand the greatest common factor and the least common multiple a little bit better. Now, there's plenty of previous videos that focus on the mechanics of finding the greatest common factor or finding the least common multiple and how to find that answer, right? But this video is really to help us understand them a little bit better so that we can read a word problem or even just a real life situation and understand when am I finding the greatest common factor and when am I finding the least common multiple. So I want to just kind of delve into how these two things just for a second before I show you a bunch of examples and problems that we can work through together. This problem right here is a problem about Jimmy and his assignment. He is making an office building or a model of a building, a skyscraper if you think of a building like that. It's in the shape of a rectangular prism, kind of like what you see in the picture right here, but we don't know how tall it is, or I'm just giving that as an example. Anyway, Jimmy has 200 blocks and he makes the very first floor. He's got these blocks. He's making the first floor using 30 blocks. So that's all we know about his first floor. That's all we know. So the question that you see down here, question number 1 says, what could the dimensions of the first floor have been? So by dimensions, of course, we're talking about the length and the width of the rectangular shape. And so you can think through what are all the possibilities that the first floor, that rectangle, could be. The second question then, once he has this first floor created, he builds up his model of the building. So he puts maybe a second floor on top of it, and then maybe a third floor or a fourth floor. We don't really know because we don't have his final product right here. But he creates a building by starting with the first floor with 30 blocks, and then he has the second floor and third floor. So the second question is, how many blocks could the entire building have been made of? We don't know how tall the building was. He could have just had a single floor and then stopped and said, that's my building. He could have had 2 floors or 3 floors. So how many blocks could the entire building have been made of? If you were to just pause this video right now and answer these questions, just kind of jot down how many blocks could it have been. Just kind of jot a list down. Maybe we don't really know for sure, but what are all the possibilities? So let's think through how do we think of these two questions. The first question, what are the dimensions of the first floor, are factors really. We're thinking of factors of 30. So we could have all these possibilities right here. The first floor is in the shape of a rectangle. It could be 5 by 6 or 3 by 10 or any of these. Our brain is working a little bit differently than when we answer the second question, which would be right here. How many blocks did he use? Here we're thinking, well, I know he used 30 blocks for the first floor, but also he could have used another floor. He could have done another 30. So now he's got 60 blocks he could have used, or maybe he made a 3-story building. Now he has 90. So if we were to list on paper all of these possibilities, we would have a list such as 30, 60, 90, 120, 150, 180, and that's it, because he only had 2 blocks. Our brain is working in 2 different ways, and this is the key to what that will help us understand how to answer word problems with GCF or with LCM. With factors, we are thinking about division. We are splitting 30 into groups. So we could have 5 groups of 6, or vice versa. 3 times 10. We're thinking of how can I divide 30. So with factors, we think of division and splitting it up. With multiples, we think of something repeating over and over and over again. We see that the first floor, this 30, repeats itself on the second floor and repeats itself on the third floor. So we see something repeating over and over and over again. We also can think of this as having multiple units of the same number. So something that's repeating, or that we see multiple events or multiple of the same number over and over again will help us understand these. Okay, let's look at some problems here. GCF or LCM. So I'm going to show you a series of problems. We'll just kind of read through them, and all I want you to do is to pause and then answer whether this problem involves finding the greatest common factor. Remember, that would mean we're thinking about dividing or splitting up into groups. Or does it involve the least common multiple, which is an event or something that happens over and over again, or some repeated amount of the same number. So here's our first problem. Okay, there's a restaurant obviously here. The restaurant's two neon signs are turned on at the same time, and both signs blink as they're turned on. So these signs are kind of blinking on and off. One sign blinks every 9 seconds. The other sign blinks every 15 seconds. In how many seconds will they blink together at the same time? Again, will we be thinking about GCF or LCM? In this problem here, since something is happening over and over again, we would think that this is an LCM problem, a multiple problem, because the same numbers are repeating over and over again. We can write down how many seconds go by on the first sign. It blinks every 9 seconds. So we could say 9. At 9 seconds it blinks. At 18 seconds it blinks. At 27, 36, 45. It is an event that is occurring over and over again every 9 seconds. And then we can also write down the other one, 15 seconds. That's an event that's happening every 15 seconds. When do they happen at the same time is the common multiple. So the least common multiple is what we want to get there. Question number 2. The school cafeteria serves pizza every 6th day and applesauce every 8th day. So if pizza and applesauce are both on today's menu, and how many days will they be together again on the menu there? So think about this one, and what do you think? If you chose the least common multiple, you would be correct, because once again, this is an event that happens over and over again. Pizza every 6th day. So on the 6th day of the month, pizza on the 12th day, on the 18th, and so on. And then applesauce, we could keep track of that as well. So least common multiple is an event that occurs over and over again. Question number 3. Alvaro and his friends are going on a camping trip. He has 18 apples and 30 pieces of gum. He wants to make bags of apples and gum that have the same number of apples and gum in each bag. So what is the greatest number of bags he can make so that there's no apples or gum left over? So just in case you're ever in this situation, you would need to know what kind of problem this is. So go ahead and think about this one. And if you said greatest common factor, you would be exactly correct, because in this case he has two types of things and he is making groups. So he has to think about how to divide them into groups. So he's thinking division, which is what our brain does when we're trying to think of factors. So greatest common factor is correct. Fourth problem here, there's a party at the drama teacher's house. There's 20 cookies and 40 carrot sticks. Isn't that a wonderful combination of refreshments there? Each cast member had the same number of whole cookies and the same number of whole carrot sticks. Nothing was left over. They ate all of it, and the drama teacher did not eat any of it right there. So how many cast members might have been at the party? If you're thinking about factors, then you're exactly correct here, because we're thinking about how to divide these up into whole numbers. Notice that this problem is a little bit different because it's not necessarily asking for the greatest common factor. It just says how many cast members might have been at the party. The answer could have been 2. Only 2 people. They split 20 cookies and 40 carrot sticks. So that would be just wonderful right there. So let's check here. Good job there. Question number 5. All right, there are 64 girls and 56 boys on the 6th grade team. So how can we make groups that have the same number of girls and the same number of boys in each group? All right, if you said factors again, if you're thinking about how to divide this up and how to make groups and split it up, that is a greatest common factor type of problem. So you're exactly right in finding the greatest common factor. Delta airplanes, you know Delta, the airline, take off every 12 minutes from the airport. AirTran airplanes take off every 10 minutes from the same airport. So If the two planes take off exactly at the same time, well, how many minutes will go by before they take off together again? So think about this one. What type of problem is this? And if you answered multiples, so this is the least common multiple, then you'd be correct. This is describing events that occur over and over and over again. So we're listing multiples and we're trying to find out at what time are they both the same. So that is all of them. Yes. You're welcome. You're welcome. Yes. Okay, so good job. Those are some examples of these type of word problems, and that's all I have for you.